Okay, vectors, page 2. Again, I'm finding the velocity and acceleration when t is pi over 2. Remember, the velocity is the derivative, first derivative, acceleration is the second derivative. So my velocity vector, and a lot of times you write vectors with little corners. Derivative of x is going to be negative 4 sine of t. Derivative of y is 2 cosine of t. And I'm going to plug in pi over 2. Negative 4 times sine of pi over 2 is negative 4 times 1, which is negative 4. 2 times cosine of pi over 2 is 0. And then the acceleration is going to be the derivative of that. Derivative of sine is cosine. Derivative of cosine is negative sine. Plug in pi over 2. I'm going to get cosine of pi over 2 is 0, and sine is 1. The speed. Well, the speed was just the magnitude. So it's going to be the square root of dx dt, which I already have. This is dx dt at pi over 2, and this is dy dt at pi over 2 squared. So it's going to be negative 4 squared plus 0 squared, which is the square root of 16, which is just 4. Draw the path of the particle and show the velocity vector at pi over 2. In order to draw the path, I need to put it in rectangular. So I need to know that x equals 4 cosine of t and y equals 2 sine of t. And my formula relating my rectangular and my polar, not polar, vectors, is I know that sine squared plus cosine squared equals 1. Well, this is almost cosine. This is almost sine. So could I say that cosine squared, sine squared, y over 2 squared plus, x over 4 squared equals 1. So this is really y squared over 4 plus x squared over 16 equals 1. This is an ellipse that's going to go out. It's just going to look something like this. And you could have graphed this on your calculator in parametric mode. A vector is parametrics with arrows on the outside. That's basically all it is. And the last thing is the arc length. Well, that's the integral from 0 to pi of the dx dt squared plus dy dt squared. So that's sure dx dt negative 4 sine of t squared plus 2 cosine of t squared. dt, I stick that in my calculator and I get 9.688. Arc length formula, same as parametrics.